No matter what your business is, whether it's hauling materials on high-speed interstates, navigating on busy city expressways, or transporting the most valuable cargo of all, people, on crowded city streets, it is your equipment that you rely on to get the job done effectively and safely. It's hard to imagine a more vital part of safe, reliable operation than the air brake systems, and that's what this presentation is all about. A typical air brake system can be divided into several distinct parts: the supply system, the front and rear service systems, and finally, the trailer. This presentation is the first of a four-part series and deals with the operation and maintenance of the air supply system. During the program, we'll point out areas of maintenance concern. Although brake systems and components may vary from vehicle to vehicle, the air supply system, shown here in blue, is basic to all. The major components are the air compressor, supply, front axle, and rear axle service reservoirs, governor, and air dryer. The primary component of the supply circuit is an air compressor, such as this Bendix 2-Flow 550. Powered by the vehicle's engine, the air compressor converts atmospheric air into compressed air, energy needed to power the vehicle's brakes. The compressor components we focus on during this presentation are the crankshaft, connecting rods, rear end cover, rear main bearing journal, pistons, cylinder bore, inlet valve, discharge valve, and discharge port. The compressor crankshaft and connecting rods convert the rotational force of the engine to a vertical linear force in the compressor pistons. The compressor is lubricated by pressurized engine oil, which in this case enters the rear end cover, flows to the rear main bearing journal, and through a passage in the crankshaft to the connecting rod bearings. Oil that escapes from around the bearings falls to the bottom of the crankcase and is returned to the engine. This oil return is important because it prevents crankcase flooding, which results in compressor oil passing. Let's take a look at the air compressor from a front view, revealing a single piston only. During the intake stroke, a slight vacuum is created above the piston in the cylinder bore, causing the inlet valve to open and move from its seat. Filtered atmospheric air flows into the bore until the piston reaches bottom dead center and begins to reverse its travel. As the piston begins its compression stroke, the inlet valve closes, and the air in the cylinder bore is compressed as the piston approaches top dead center. During air compression, the discharge valve opens, allowing compressed air to flow from the cylinder bore past the open valve and out the discharge port into the supply reservoir. Returning to our full cutaway view of the compressor, we find that since the compressor contains two cylinders and the crankshaft has 180-degree opposed journals, one piston will be on its intake stroke while the other is compressing, building to maximum pressure. While this is occurring, a constant flow of engine coolant is routed through the cylinder head cavities to dissipate the heat generated by the compressor during air compression. Rapid buildup of air pressure depends upon proper opening, closing, and sealing of both the inlet and discharge valving and unobstructed flow of air in the cylinder bores. Check for any restrictions to the flow of atmospheric air into the cylinder bore or the compressor discharge line leading to the supply reservoir. The obstruction of atmospheric airflow into the cylinder bore will cause the vacuum above the piston to draw oil past the piston rings, resulting in oil passing. An obstruction in the compressor discharge line leading to the supply reservoir will cause the compressor to run hot, build carbon deposits, and pass oil despite adequate coolant flow. Next, let's look at the Bendix D2 governor and how it interacts with the compressor and supply reservoir and later the air dryer. The governor is used to control the compressor and thereby regulate air pressure in the supply reservoir. The governor's main components are the reservoir port, piston, inlet exhaust valve, pressure setting spring, and governor unloading port. An air line connects the governor to the supply reservoir. Reservoir air enters the governor at its reservoir port. As air from the compressor builds reservoir pressure, the governor's piston and valve move together against the resistance of the pressure setting spring. When reservoir pressure reaches the cutout setting of the governor, typically 120 psi, the piston will have moved sufficiently to seal the exhaust and open the inlet. Reservoir pressure flows past the inlet, through a passage in the piston, and out the governor unloader port to the compressor unloader mechanism. Air from the governor enters the compressor and acts upon the unloader pistons, which move and hold the compressor inlet valves off their seats. With the compressor unloaders pressurized, air enters and leaves the cylinder bores through the open inlets, and air compression ceases. Because the pistons are 180 degrees opposed, air is shuttled from one cylinder to the other as the pistons move up and down. When supply reservoir pressure drops to the cut-in pressure of the governor, typically 100 psi, the governor pressure setting spring moves the piston, closing the inlet and opening the exhaust. Air in the compressor unloader mechanism flows back to the governor and is exhausted. With air pressure removed, springs move the unloader pistons, allowing the inlet valves to return to their seats, and the compression of air resumes. Here's a service tip. Make sure the air line between the supply reservoir and governor is unrestricted. Otherwise, the governor's function will be impaired. If either the governor or compressor unloader mechanism fail to function, the compressor would continue to compress air. To protect the air systems against a failure of either the governor or compressor unloader mechanism, a safety valve like the Bendix ST3 is installed on the supply reservoir or air dryer if the vehicle is so equipped. Generally set to open at 150 psi, the safety valve employs a spring-loaded stem resting on a seated ball valve. When reservoir pressure exceeds the valve setting of 150 psi, the ball moves off its seat and air is exhausted through the exhaust port. The safety valve should be checked periodically by pulling the exposed stem. Air should escape when the stem is pulled and cease when released. A dual circuit brake system generally consists of a minimum of 3 reservoirs: the supply reservoir, the front axle service reservoir, and the rear axle service reservoir. The service reservoirs supply both the front and rear axle brake circuits. Air from the supply reservoir flows through single check valves to fill, protect, and separate the service reservoirs from each other. The Bendix SC1 single check valve allows air to flow in one direction only. The Bendix SC1 consists of a supply inlet port, inlet valve, spring, valve seat, and delivery port. Supply reservoir air pressure overcomes a light spring force to move the valve off its seat, allowing air to pass through the valve into the service reservoir. If the supply reservoir air pressure is lowered for any reason, the check valve closes and prevents service reservoir air from flowing back into the supply reservoir. As required by federal regulation, braking pressure for each service reservoir is registered on a dash-mounted air pressure gauge or gauges. A low-pressure indicator switch, such as the Bendix LP3, is installed on both service reservoirs. Also required by regulation, the LP3 activates a visual warning, generally a dash-mounted warning light and a buzzer. When reservoir pressure falls below a safe minimum, typically 60 psi, electrical contacts in the low-pressure indicator switch close. They remain closed until reservoir pressure rises approximately 15 psi above its safe minimum setting. In addition to providing a place to store air, the reservoirs also serve as a collection point for contaminants produced during air compression, such as water from the air and oil from the compressor. Oil, water, and vapor are contained in the hot pressurized air from the compressor. When cooled in the air lines and reservoirs, these contaminants condense and collect in the bottom of the reservoirs. Removal of these harmful contaminants is essential to ensuring proper valve operation. This is most easily accomplished using a simple drain cock, which when opened permits air pressure, along with contaminants in the bottom of the reservoir, to be expelled. The check valves and low-pressure indicator can be tested by observing the reaction of the dash gauges and low-pressure warning device as air is drained from individual reservoirs using the drain cocks. It should be noted that some vehicle manufacturers install a single low-pressure switch located on the supply reservoir rather than one on each service reservoir. Although drain devices remove accumulated contaminants from the reservoirs, the air system remains 100% saturated with water vapor, which will condense when the temperature falls. To solve this problem, a desiccant air dryer, like this Bendix AD9, is installed to remove 100% of the liquid and solid contaminants and approximately 95% of the water vapor prior to entering the brake system. Before we take a closer look at the air dryer's role, let's examine its main components. The air dryer includes the supply port, end cover sump, oil separator, desiccant cartridge, desiccant drying bed, check valves, outer shell, delivery port, control port, purge valve piston, purge valve, turbo cutoff valve, and exhaust port. The air dryer is installed in the discharge line between the compressor and the supply reservoir, and also interacts with the governor. Air and contaminants from the compressor enter the air dryer supply port in the end cover. Air traveling through the end cover cools, causing some contaminants to condense and drop to the sump of the end cover. Upon exiting the end cover, air enters the oil separator, where the remaining solid and liquid contaminants are removed. Still saturated with 100% water vapor, air flows from the oil separator to the desiccant cartridge. Air flowing through the desiccant drying bed becomes progressively drier as the water vapor adheres to the desiccant material in a process known as adsorption. While some air will flow through the orifice adjacent to the check valve, the majority of the dry air exits the desiccant cartridge through its integral check valve to fill the purge volume between the desiccant cartridge and outer shell. Dry air in the purge volume flows toward the end cover and passes through the single check valve, out the delivery port, and to the supply reservoir. The air dryer will remain in the charge cycle until air brake system pressure reaches the governor cutout setting of 120 psi. The same signal of air from the governor which causes the compressor to unload also starts the air dryer purge cycle. Air from the governor enters the control port of the air dryer, moving the purge valve piston. The turbo cutoff seals the inlet port and opens the purge valve. Contaminants in the end cover sump are expelled from the open purge valve. To protect the supply reservoir against air loss, the check valve closes. At the same time, air in the purge volume and air passing through the desiccant cartridge reverse direction as the purge valve is opened. Air from the purge volume passes through the orifice adjacent to the check valve and expands to near 0 psi, becoming super dry before flowing into the desiccant cartridge. This super dry air regenerates the desiccant material by stripping away accumulated water vapor. Contaminants in the oil separator are also carried away through the open purge valve. Closing the dryer inlet port during the purge cycle ensures that loss of engine turbocharger pressure is minimized in the event the compressor intake is connected to the turbo. The entire purge cycle is complete in about 25 seconds. The purge valve will remain open until air brake system pressure is reduced to the governor cut-in setting of 100 psi. When the governor exhausts air from the compressor unloaders, air is also removed from the air dryer purge piston. With control pressure removed, the piston moves in response to its spring and closes the purge valve. The charge cycle repeats. Since the air dryer is controlled by the governor, which in turn reacts to supply reservoir pressure, it is important that air leakage in the supply reservoir be minimized for proper air dryer operation. Leakage in the supply reservoir will result in the compressor cycling between loaded and unloaded, causing the air dryer to alternate between the charge and purge cycle. It must be remembered that air loss in the supply reservoir only will not be registered on the dash gauges because of the single check valves that protect the service reservoirs. With the addition of the air dryer, the air supply system is complete. But before we close, let's quickly review what we've discussed during this presentation. The air compressor is the heart of the system. Driven by the engine, it produces and transmits compressed air to the supply reservoir. The governor connected to the compressor, air dryer, and supply reservoir maintains system pressure between a preset minimum and maximum by controlling the compression cycles of the compressor. From the supply reservoir, air flows into the service reservoirs, which are separated and protected by single check valves. Each reservoir in the system is equipped with a drain cock to drain away accumulated contaminants. With an air dryer installed, contaminants are eliminated before they can enter the system. Finally, low-pressure indicator switches and dash gauges keep the operator appraised of available brake system pressure. We hope this detailed look at your air supply system and its components has enhanced your understanding of the air brake system. Part 2 will discuss the operation and maintenance of the service brake system. For more information and a complete Bendix service manual, contact your local authorized Bendix parts outlet.